Hello friends, so let's start with a very interesting topic of partial differentiation which is called as composite function. So here I'm gonna tell you what is the definition of composite function and let's understand the concept of composite function through an example. So guys, what is meaning of composite word? So in English we say composite is nothing but the combination of two or more elements. So you must have heard this word in chemistry. So guys, here the composite function has the same meaning. It means it is a function which is combination of two or more functions. So let's see how that composite function looks like and then how to find the partial differentiation of such composite function. So here in front of you we have the definition of composite function. So here I have considered one function, that is z, which is a function of x and y. You can see here. Then x is a function of t and y is also a function of t. So here we have written x is phi of t and y is psi of t. So guys, these are just the symbols given to denote the function, as we take f to denote the function. So x and y are the functions of t and z is a function of x and y. So guys, if I see this z, then z is related with t through x and y. So z is function of x and y are function of t. So z is related with t. So whenever one variable is related with another variable, or let's talk it in the technical terms, when the independent variable, that is the t, and z, which is the dependent variable, they are related with each other through some intermediate variable like x and y, then such function is called as composite function. So here we can call that z is a composite function of t. So to understand this in easy manner, we always solve this composite function with the help of tree diagram. So here guys, I'm going to draw the tree diagram and then let's revise this concept once again. So here is a function of x and y. Next, x is function of t. So here I'll say it's a function of t, and y is also function of t. So it means z is function of t through x and y. So guys, as I told you that z is called as dependent variable because it is dependent on t. So here I'll write. Then x and y are the independent, t is the independent variable and x and y are intermediate variable. So we know that in any function, the one variable is dependent on one or more other variables. So that dependent variable here is z and the independent variable is t, not x and y. So here if you see z is function of x and y, few people feel that z is dependent on x and y. It's true, but it is not directly dependent on x and y. It is dependent on t, and those x and y are dependent on t, and then z is dependent on x and y. It means I can say that z is dependent on t. So guys, you have to remember this. Now whenever the differentiation will be asked in the exam, what we have to do is we have to take the relationship between dependent and independent variable. So whenever show that question will be there, we'll see the both side, that is LHS and RHS, and then we'll observe the differential terms where we should have the relationship between dependent and independent variable, and such functions we can solve by using the chain rule. So guys, here I'm gonna apply the chain rule on this tree diagram. So let's say if I want to find out the value of dz by dt. So guys, here let me tell you one more thing, that here I can say that z is a function of t. So if I want to find out the value of dz by dt, then through tree diagram, how do we find it out? So as per the chain rule, we travel from the dependent variable to the independent variable. So here the dependent variable is z and independent is t. So I'll travel from z to t. So there are two paths to travel from z to t. One is z to x, x to t, and z to y, y to t. So guys, we are gonna write down that path using the chain rule. So here I'll write this part, that is z to x. So I'll write that as del z by del x. Now guys, you'll say why del is written, because if I am differentiating this z with respect to x, then y will be treated as constant, because we are finding the partial differentiation. Now from x to t, it will become dx by dt. Now you must be thinking, so why it is not del x by del t? So let me tell you that x is a function of t. It means x have only one variable, that is t. So if there is no other variable present, then we can't use the partial differentiation, or even if we use the partial differentiation, we are gonna get the total differentiation only. So here let's say with t we would have, let's say, some p, then I would have said it as del z by del t, because we could have considered that p as a constant. But here, since there is no other variable present with this t, we will get the complete differentiation. Then plus, so now when one path is completed, then we have to give sign as plus. Then let's take second part. So that will be del z by del y. So that is the first, into dy by dt. So I'm sure that you understood this, that y is a function of t only. So it will be complete differentiation. And when I'm finding del z by del y, I can treat x as constant. Now this is the chain rule. So I've applied the chain rule for both the paths. Now guys, by doing this, I'll get the value of del z by dz by dt. Now you must be thinking that since z is a function of x and y, how can we get a complete differentiation? So guys, let me tell you that here I'm saying that z is the dependent variable and t is the independent variable. Now if you see z and t, then z is a function of only one variable, which is t. So there is no other variable which we can keep as a constant, or which we can consider as a constant. Hence here we are gonna get the complete differentiation only. So this is the formula to find out dz by dt in terms of composite function. So whenever we have composite function, this is a formula which we are gonna use. Now guys, this is the first case of composite function. Now let's elaborate this concept itself for one more type of composite function. For that, we have z as a function of x and y, and x is a function of u and v, y is also a function of u and v. Now let's see what we do in this case. So here, first of all, I'll draw the tree diagram. So here I'll get z function of x and y, x is a function of u and v, y is a function of u and v. Now guys, z is a dependent, u and v are independent, x and y are intermediate, the same thing. Now if you see, then z is a function of u and v. So if I want to find out the differentiation of z with respect to u, then I can consider v as a constant, and that is why here we are gonna get the partial differentiation. So I'll first find out the value of del z by del u, and then I'm gonna find out the value of del z by del v. Now guys, to find out del z by del u, I'm gonna apply the chain rule on different paths, which is going from z to u. So one path is z to x, x to u, and then z to y, y to u. So let's apply the chain rule on that. So for first path, I'll get del z by del x into del x by del u. So this is the first part, plus the second part is del z by del y into del y by del u. Now guys, here I want to clarify two more points. One is Now since here there are two parts, here I got two different terms with plus sign in between. Now let's say tomorrow you are getting a question which is having multiple parts. So let's say three parts or four parts. So your terms will increase. So that is the first point. Now the second point, here if you see I have written del x by del u here, because when I'll find this differentiation, that time I'm gonna keep v as a constant. But in the previous case, x was a function of t only. So that is why we got dx by dt, which was the complete differentiation. So whenever we have multiple variables, that time we are going to get the partial differentiation only, because here we are finding the partial differentiation for composite function. So partial differentiation is possible if and only if we have more than one variable in the given function. So this is the formula. Now let's find it out for this del z by del v. So let's find the path. So z to x, x to v, one path, then z to y, y to v. So let's apply the chain rule. So del z by del x into del x by del v. So this is the first part. And the second part is del z by del y into del y by del v. So that is the second part. So guys, this is the value of del z by del v. So here we have seen the definition of composite function and the different cases, or I would say the examples of the finding the partial differentiation by using the composite function. So guys, I'm sure that you understood this definition and the concept. So keep watching Ekeeda to get knowledge about all the engineering subjects, and don't forget to share this video with your friends, because they can also get benefited through these wonderful concepts. Thank you very much and keep watching guys.